Good afternoon, maybe good morning for some of you. Hello and welcome to today's webinar titled Floor Flatness Requirements for Ceramic Tile and Stone Installation. I'm Jim Olson with the National Tile Contractors Association, and I want to welcome you and thank you for taking time out of your busy schedule to attend today's webinar sponsored by Custom Building Products. Before I introduce today's speaker, I want to remind you that during this webinar you will be muted. Please use the questions area on your computer to type in your questions. We will answer your questions at the end of this presentation. If the audio on your computer is poor, call the number on the invite to this webinar and listen on your phone. As a reminder, all NTCA webinars are available to watch at any time on the NTCA YouTube channel shortly after the webinars are presented. This will give you easy access to watch and or share all current and past programs at your convenience. Today's presenter, and I'm really happy to introduce him, is Howard Jancy. He is a CSI, CDT, Commercial Architectural Service Rep for Custom Buildings product. He has 30 years of experience with tile, stone, concrete flooring design, installation, and remediation. His responsibilities include specification writing and review, technical support, and continuing education. He has authored articles for numerous industry publications, including Landscape Contractor National, Journal of Architectural Coatings, and the Construction Specifier. He has been a presenter at World of Concrete. Howard is a member of the Construction Specification Institute, Chicago chapter. Welcome, Howard. I look forward to it.
All right. Thank you very much for that introduction. Again, I'd like to thank everyone attending today. As already mentioned, my name's Howard Jancy. I'm responsible for architectural and designer representation. Today's presentation, we're going to be looking at specifically floor prep requirements. If you're not familiar with custom, we make a variety of setting materials, starting with surface prep products, working all the way through the grout line. So we offer you a complete system for installing tile and stone. Today's presentation is blessed by AIA for continuing education. If you need a certificate of completion for this presentation, you must email me with that request. There's the email address at the bottom. So if you need a continuing ed certificate, it's only going to happen if you email me. A couple things to reference or comment on. Tile setting methods and materials are not random, arbitrary, casual choices. There are several guidelines published and standards published by the TCNA that are beneficial to all parties involved with tile products, tile installation. The book on the left is the TCNA handbook. It contains an incredible number of generic details on installing tile in every conceivable location, interior, exterior, etc., etc. Also, looking at the ANSI book on the left, all setting materials have standards. There's two standards for each setting material. One describes the minimum performance characteristics of the product, such as grouts. The other standard will tell you how that grout is typically installed. So all manufacturers of setting materials manufacture products that conform to the ANSI standards and will work with the details that are shown in the TCNA handbook. So again, if you'd like copies of one or both, email me with your request. Large format are tiles that are 24 inches or greater on a side, and I was recently informed of that change. It used to be 15 inches on a side, now it's 24 inches on a side. So all these tile products that are pictured require a flat substrate. Any deficiencies in the slab that are not corrected can lead to problems, from tiles cracking, grout lines failing, or minimally maybe aesthetic issues. If you don't have a flat substrate for these very large tiles, you have a variety of problems. Tile longevity, both the aesthetic longevity and functional longevity, will be compromised. Tile lippage is a physical and aesthetic issue, but could also be a trip hazard if it's installed in the area where people are moving along with walkers or canes or foot shuffling. Mortar coverage is impacted if you don't flatten the floor first. Too much or too little mortar, again, there will be problems. So surface prep is very important. There's sometimes the thought, well, I'm going to throw a membrane down, I'm going to install some mortar, there's going to tile was going to be installed, so I don't need to do surface prep. No one's going to notice. They will notice as that flooring system fails, and it definitely will. As far as floor flattening, the requirement for tiles greater than 15 inch for large, greater than 15 inch, you'll see there in the middle of the slide, is no greater deviation than 1/8 inch in 10 feet. If you have a floor flatness problem greater than 1/8 inch, you're going to have to remediate or fix that, meaning getting it below 1/8 inch in 10. And if you're on smaller tiles, the requirement is 1/4 inch in 10 feet. Those are the standards. And in the case of working with vinyl carpet or wood, you've got no greater than 3/16 inch in 10 feet. But what's the reality if we're talking new concrete? Typically on a commercial floor, the best you're going to see is about 1/4 inch in 10, maybe even worse. So really all your tile installations, whether they're new concrete or remediation on existing concrete, you're probably going to have to do some flattening of that surface before you install any tile setting material. Membrane, mortar, or tile needs a flat floor to be properly or correctly, to have the correct installation. Now, as far as measuring floor flatness, there's, I guess, two methods that are employed. On the left, we see what a tile contractor will be doing at some point prior to the tile installation. That person will be throwing down a 10-foot straight edge and looking for daylight underneath that straight edge. And any daylight or gap greater than 1/8 inch 10 is going to have to be flattened first. The other method of measuring floor flatness is in a specification. A floor flatness number is specified, and we'll talk more about that later. And that FF number, that measurement is taken within 3 days after that concrete slab is placed. So these methods of measuring floor flatness are very different, and the biggest difference is the timing when they occur. And the floor flatness, measuring the slab soon after concrete placement, that has an ASTM standard. It's very precise how that's done. Whereas the straight edge, as we see on the left here, the contractor will put the straight edge down as many times as he wants in any and every direction that he wants across construction joints. Whereas measuring FF numbers, it's a very precise, regimented process, if you will. But the biggest difference between these measurements for floor flatness, substrate flatness, is the timing. Looking on the left there, straight edge measurement is done prior to the floor installation. FF numbers are measured, have to be measured within 72 hours after slab installation. And what's wrong with that? Well, I'll tell you. If you look on the right picture there, you've got a deformed curled slab. As ready mix concrete dries, it will deform and curl because the bottom stays damp, the surface is drying out quicker, so you get that upward curl. However, all that deformation is not started yet or is not seen 3 days after the concrete is placed when FF numbers are measured. So if you're installing tile weeks, months after the concrete's been placed, it now looks like a potato chip, curved, because again, moisture has evacuated or left the slab, and that deformation is a given. So what is measured as flat 3 days after installation of the substrate is not flat when you, the tile contractor, runs out to that slab for your installation. And what's more likely is what you see on the left. Look at that straight edge going from left to right. You've got a gap that's maybe, I don't know, a 1/2 inch, 3/4 of an inch. And I'm sure it looked flat or was measured flat with an FF number 3 days afterwards. So no matter how perfect you place that slab, it's going to deform. It's going to change shape. It's not going to be flat enough 1/8 inch and 10 for these large format tiles. So as I already mentioned, probably for every installation, you may have to think about how you're going to flatten that surface first before you start the tile installation. FF numbers, your typical commercial floor, if an FF number, flatness number is specified, it's around 25, 30, maybe 35, and that roughly correlates to about 1/4 inch and 10. These correlations between FF number and 1/4 inch, for example, 25 to 1/4, there is no industry direct correlation. These are, I guess, best guesses, if you will. And look, to get a 1/8 inch and 10, you need a FF number of 50. And the simple fact here, as you increase FF number going 25 to 50, maybe even to 100, the methods and materials to install that very flat concrete floor, it affects the cost of installation. So if you want a super flat floor at the time of installation, you're going to have to change your methods and materials. And then when I say you, that means the concrete contractor. So rather than striving for a super flat floor at the time of installation, it's easier to do it with a leveling product prior to the tile going down. We did some internal testing using a self-leveling underlayment and did an FF number measurement on that underlayment, and we could hit about an 86.6 FF number. So again, that gives you your 1/8 inch and 10 that's required for large format tile. So in specifications, you may see FF numbers prescribed. You just may see some general comments that if need be, use leveling materials and patching compounds to get that slab prepared. But realize the most perfect slab at the time of installation may not be perfect when the tile contractor goes out to the job site. Self-leveling underlayments have two standards. One is a product standard, 18.6. All manufacturers of leveling materials, their products will conform to this standard. 10821 is the method standard, tells you how that product is typically installed. So if you're looking at a manufacturer's self-leveling tech data sheet, product information, these two standard numbers should be popping up. You'll know that they're meeting the minimum requirements set by TCNA and ANSI. So these are the two standards that are available for leveling products, cementitious leveling products. And here's some of the highlights of the product standard. These standards are only for ceramic tile and natural stone. I know manufacturers of other types of flooring materials may rely on this, but again, this standard was written around tile and stone. I will discuss it a little bit more later, but all manufacturers of leveling materials, they have different recipes, different formulations to do different things. So again, all those various products have to conform to this same standard. There's a minimum strength requirement. These leveling products have to have a heavy service rating as measured by an ASTM standard. So there's very precise requirements for what that product can do or has to do. And if you open up ANSI 18.6, here's a list of the minimum requirements for those products. The flow rate, how far it flows once it's poured out. That's done with pouring a set amount of material out and watching it flow. The compressive strength, the tensile bond strength. Again, these are all the minimum requirements. Also, take a look at healing. Healing, the time is when you take a gauge rake or paddle to that leveling material. Once you remove that tool, do you leave any marks in the surface? So again, that product has to be workable for greater than 10 minutes. So these are, again, minimum requirements for self-leveling, cementitious self-leveling underlayments. This is important to note. In the past, I have used the words flatten and level interchangeably, and they're not the same terms. They don't mean the same thing. The products we're talking about today are intended to flatten and not level the substrate. And what is the difference? Take a look at the right. The top floor is level, but it's not flat. So we're going to have to fill in those depressions, if you will, before we start the tile installation. Looking at the bottom, that floor is flat, and yes, we can install tile on it. It's perfect, it's flat, but it's no longer, or it's not level. So what we're talking about is flattening a floor, not leveling it. And if leveling is required, it has to be clearly specified in section 09-3000. And if you're going to be if you're going to be doing leveling, understand it's a more costly process. The surveying of the surface, the measurement of the surface, and very likely you'll be using more material to level a floor than you are flattening it. And understand, if you're doing remedial work where you have walls, doors, etc., already constructed, you may not be able to level because of elevation changes that are going to happen. And I bring this up because if you're a contractor looking at quoting a project and they specify leveling and you throw out a bid for flattening, you're not going to have enough money in that job to do that correctly. Or if you're a specifier, you need the floor flattened, or excuse me, you need the floor leveled, but you only specify flattening, it's not going to get done until someone comes up with more money for that contractor. So flattening and leveling are two different end results. Understand the difference when specifying or bidding a project. If we look at a manufacturer's leveling products, they have multiple formulations generally. And if you look at the green highlights there, we have products that are low in cost. They have different working times, different depths of pour. So there's a lot of different products where you as a contractor can laser in on the specific needs of that particular project. Or if you're a specifier, you could laser in on the specific concerns of that flooring installation. So every manufacturer has different products, each achieving or either that affect the cost, workability, or performance of that leveling material once it's in place. Now, the question is, why can't there just be one product to do all these wonderful things? If you look at the recipe or ingredients in a self-leveling product, you have different types of cement. You've got all these various ingredients, and these ingredients will change a little more, a little less, depending on what you're trying to do on the left there. So each of these products on the left is very much different. The recipe is different, and that's why you just can't have one product that does everything. Now, most manufacturers have a leveling material that is the workhorse that will handle the majority of your job, but realize you can laser in, as I like to use the term, on other qualities or characteristics of the product to handle your installation within budget and within your performance capabilities. So again, these underlayment products are very chemically sophisticated materials, and again, their performance, the subtle performance characteristics are dependent on the ingredients that you see on the right. Now we're talking about leveling materials to prep a floor prior to tile installation, but you also have available to use patching and skim coating products. These can be used by themselves or in conjunction with leveling materials. The trowel grade patch that we see on the top right, you could be filling in cracks with that, non-moving cracks. You might have a isolated depression or deviation in flatness that you don't need to level the whole floor. You may use a patching compound instead. That skim coat and patch is a technique that you might use if you're placing a vinyl or LVT product, because very subtle deviations in the surface that may not impact tile can reflect through or shadow through on that vinyl or soft flooring. So you have a range of products available. There are a range of products available for prepping the floor relative to flatness. The fluid applied, or excuse me, the self-leveling materials and or trowel grade materials as we see here. It's important to understand that you should not use the thin set or the mortar that is for leveling or flattening the substrate. Mortars are used for adhering the tile to the substrate. They're not designed for flattening. So we see in the pictures there a skim coat material or patching material. On the right, we see the self-leveling material being applied. And the reason being, you don't want to use the mortar should be applied in a uniform thickness. If you have thick and thin sections of mortar, you could create voids underneath the tile or high points and shrinking that are going to cause the tile to crack at some point. So you flatten the floor first so that when you're combing out the mortar, you're combing it in a uniform thickness across the whole surface. Again, you don't want a very thick section here and a very thin section there. They will cure at different rates. You'll have shrinkage, and again, you will have problems with your tile floor after the application. If you look at the left picture, you'll see the mortar has been applied about 1 inch thick, much too thick. Just isn't going to work because that will shrink. It's going to cause defects in the surface or the tile. And that's what they're doing. They're tearing out the tile floor now. And if you look at the lower left there, you'll see your typical thin set should be no thicker than a 1/4 inch after you embed the tile. Your mortars that are specifically designed or formulated for large and heavy, the large format tiles, generally no greater than 1/2 inch after you embed the tile. So if you're trying to flatten the surface and adhere a tile, you're more than likely going to use too much mortar and you're going to have problems. And what types of problems? Here's the extreme of misapplication of the mortar, thick and thin. We see spot bonding. How do I know it's spot bonding? Because you could see the cracks, the circles where spots of mortar were put down, and the mortar was too thick. It shrunk, and it cracked the tiles. So there's your spot bonding, creating cracks in the tiles, and that's your extreme in too much mortar used underneath the tile. So spot bonding is a no-no with the cementitious mortars. Here we see another example of spot bonding where the mortar was combed out and then spots of mortar were put down, and you could see that blur there is a rubber mallet. So even beating the tile, in this case a glass tile with a rubber mortar, does not collapse the ridges. You're going to have excessive mortar there, and at some point you're going to have cracked tiles. So you want a flattened surface first, and then you can apply your mortar uniformly when you comb it out. That way you get good coverage once that tile is embedded. And mortar coverage, the minimum requirement is 80% coverage. For ceramic tile, I also like to include or recommend 95% coverage for wet areas or where you have thermal cycling or high impact or rolling loads. But the minimum standard requirement is 80%. Natural stone, because it's weaker than ceramic tile, porcelain tile, the minimum is 95% coverage for all installations. If you want 95% a coverage rate on your installation, talking to the specifier, you have to specify that number. If you don't, you will get 80%. And also a comment to the specifiers, you never specify mortar thickness. You specify mortar coverage, 80%, 95%, and it's up to the contractor to figure out what size trowel to use, and and what will help him figure that out. The setting material manufacturer generally will supply recommendations for size of the trowel, meaning the notches. So again, mortar coverage, correct mortar coverage is greatly enhanced or ensured if you have flattened that floor first, meaning 1/8 inch and 10 for large format tiles, 24 inches or greater. Surface prep, in addition to the leveling, which we just talked about extensively, is obviously you need to remove all contamination. All the setting materials that you need for tile setting, leveling, membranes, mortars have to bond to the substrate. So anything foreign on the surface, you're going to get a weak or non-existent bond line. And in this particular picture, that white material, that's residual mortar from the prior or the previous tile floor that's been removed. And you see some light and dark gray. The dark gray is the original concrete. The light gray, it's lighter now because again, a grinder ran over that surface and ground it down a little bit. So if I see this patch quilt of conditions, light and dark gray, residual mortar, I know that's not properly prepped. You're going to have some bonding issues with the materials that are typically used to install tile. This floor has been properly prepped. I think from the pictures you can appreciate the profile, the roughness that's been created. I think you get a sense of the porosity or opening up the slab to better absorb or hang on to these materials that have to adhere to the substrate. And you may even find some cracks that have to be corrected before tile installation. This level of thorough prep was done with a blast track machine. It spits out a BB, so to speak, removes contamination, removes weakened concrete, removes foreign materials that will be a bond breaker, and creates a nice roughened profiled surface to hang on to the setting materials that we're talking about today. Now this is done, this machine, particular machine, piece of machinery, you're going to be doing in large open areas. If you have a smaller installation, there is smaller equipment. Everyone that's familiar with floor prep products or methods, they should be familiar with a standard called concrete surface profile. That guideline has a scale of 1 to 10, 1 being very light prep, 10 being very aggressive. For the types of products we're talking about today, tile setting materials and the levelers included, typically a CSP3 is required, which means you're either grinding the floor or shot blasting. That's scabbling or scarifying, much too aggressive typically for our needs. So read your manufacturer's tech data sheet for whatever product you're working with, or specifically today for leveling materials. What do they require for surface prep? It may not be a CSP3, but understand what they require so you don't void a warranty or have problems down the road. So surface prep, very important aspect for all the products that are used to install tile. Also like to talk about surface prep as it relates to joints in the concrete. The concerns we have with concrete, typically expansion joints, which allow the concrete to expand and contract in response to temperature changes. We also are concerned with control or contraction joints. These, for today's presentation, are saw cuts that minimize random cracking as that concrete dries. New concrete has a lot of water in it. And as that water leaves the slab, it's going to start to shrink. It's going to start to deform. And by putting saw cuts in strategic and specific locations, you minimize random cracks. And then the other type of joint, if you will, consider that our existing cracks. If you're working on an older concrete slab, cracks may have developed over time. You have to understand the function of these joints and the importance of these joints, so when you install tile, it's done correctly. And here we're looking at two TCNA details, F205, F205A. This shows you if you've got an expansion joint in the concrete, that has to move up through the slab, up through the underlayment, up through the tile assembly, all in the same plane. Here's the TCNA detail that tells you how all those components work together or should be installed. Very important if you're reading a specifications that the correct TCNA details are listed. Also, EJ171, that's the detail or all the information you need for movement joints. So there's a lot of good information in the TCNA handbook that I mentioned earlier. Or in the case of an existing crack, Again, here's all the components you need to successfully install a tile floor over a crack. And the methods here are utilizing a either a partial or full membrane. A partial, you're just covering over the crack. A full membrane, you're going wall to wall. But again, this is very important to understand how to install the tile. And here, one of the important aspects too of this installation is that on one or both sides of the tile that crosses over the crack, the joints are filled with a flexible sealant, not a rigid grout. And understand the crack that we're showing here has been determined to be non-moving. And if it is moving, it's either it's determined to be moving by the architect or engineer, then you're reverting back, to this installation. But the point I'm trying to make, the TCNA handbook has lots of information on how to address tile installations with movement joints in mind with the underlay materials that we're talking about today. Non-moving, it's underlined. Non-moving cracks, and I'm not talking movement joints, non-moving cracks can be filled. They can be routed out, and oftentimes you can use an epoxy product to fill or weld those together, or you could use a trowel grade cementitious material. And if you have existing cracks existing cracks in concrete, it's very important to fill these. One, if the crack is full depth, you may be placing a underlayment product, and that it's going to flow through the crack into the occupied space below or into the soil below. You're going to be wasting material. Also, if that crack is not filled first, you're going to be placing the underlayment material, and it's going to look perfect when you walk away, but you come back a half hour later, some of that material has seeped into that open crack and created a blemish in the surface of that underlayment, and that's going to be a problem too. So fill your non-moving cracks, so again, you don't get leakage, if you will, or defects that mirror through or reflect up through the underlayment material once it's cured and hardened. An important part of a self-leveling installation is a primer, is the primer application. Once the surface has been cleaned, you're ready to go. The primer, and what we're looking at here are one of possibly two problems here. When the primer was applied, it was not applied evenly. The contractor skipped some spots, and we can see that where the concrete is still showing through the surface, or the concrete was so absorbent at those points that the primer was applied and immediately sucked in. And those are the two issues. You want a uniform film over the entire surface, not this random here, there, here, there. You're going to have problems. If the primer is properly applied, the substrate doesn't suck moisture out of the underlayment product. If the underlayment is drying out because the substrate is so absorbent, you affect the durability of the underlayment, the compressive strength, and surface integrity. So you're going to have a weakened underlayment if the surface is not properly primed. If the substrate is sucking moisture out of the underlayment, you affect the flow rate, heal rate, and working time in the product. Again, it may lead to defects in the surface underlayment once you walk away. Primer applied to the surface, it gets absorbed into the substrate and strengthens it some way. This is not to say that you could ignore shot blasting or grinding. If you have weakened surface or contamination, putting a primer over it does not solve its problem. You still have to do surface prep, mechanical potentially. The binder or primer just helps with the integrity of the surface, adds a little bit of muscle to it. Another reason to use primers, we see an underlayment product that's been applied, and look at all those pock marks that you see there. And what that is telling me, all those little pock marks are bubbles that came up through the underlayment when the air was evacuating the concrete slab. It wasn't primed, so any air trapped in the slab migrated to the surface before the underlayment was fully cured. And since the slab or substrate was sucking moisture out of the underlayment, you've got a weakened underlayment. And that's shown here by taking that quarter and scraping and dusting the surface. If that underlayment was properly hydrated without losing moisture soon after application, that surface you would not be able to scratch it as easily as we see here. So primer is very important. It should not be taken lightly because it dramatically affects the performance of the concrete, or excuse me, of the underlayment. And earlier we showed the ingredients in an underlayment, the recipe, all the various components. You start playing with the water, you dramatically change how those various components react or act with one another. So water is very important. Once you mix it in, make sure it's not absorbed by the substrate, as we've shown in the last few slides. Another area of concern, you've got an existing concrete slab, it's been trenched for whatever reason. And look, they've applied primer, but it's been absorbed in almost completely on that trench surface. So contractor needs to go back and reprime it. And generally on very, very porous substrates, what's typical, read the manufacturer's tech data sheet for primers, but you dilute with water the first application so it could readily soak in, and then you apply a second application full strength to handle this very porous substrate. And the other concern with this particular installation, what if this is a slab on grade and you have moisture that's now going to come up through that trenched area and affect the flooring product, the flooring setting materials or the product, and that's very possible. And that's what we see here. This is a brand new wood floor. It was placed on a concrete slab that never had moisture problems, and that dark area is moisture that came up from the bottom side of the slab and darkened the wood permanently. And why did they happen? They trenched the floor for that electrical sockets or receptacle that you see there. And what they should have done prior to putting the wood floor down was covering that trench area with a moisture mitigation membrane, covered the trenched area plus, let's say, 6 to 12 inches on either side. So primers don't solve this issue, but realize if you're working on a trenched substrate, you may have moisture issues that have to be corrected with a moisture mitigation membrane before you use underlayment or any other tile setting material. Manufacturers have different primers depending on what the substrate is, what you're trying to achieve. So again, read the tech data sheets from that manufacturer so you're doing it correctly. Typically with absorbent substrates, as I mentioned, you're using a diluted primer followed by a full strength application. That is brushed in to help absorption into that porous substrate. Non-absorbent, you could do with a roller. The caution here, more primer is not better. You don't want to apply it so thick that it doesn't cure uniformly, or it might still be tacky when the underlayment goes down. So more is not better with the primer, and that might be an issue, if you will, on non-absorbent surfaces versus absorbent. But priming, important part of the self-leveling application. Now, what we're looking at is a drop of water on the right that has beaded up because that surface is dense. There's something foreign blocking the pores, but there's something there not allowing that water absorb in. And believe it or not, there is an ASTM standard for this test, how to do it correctly. And where this is useful, if you're trying to evaluate, is the substrate excessively porous or non-absorbent, just put a drop of water, put it down very close to the surface. Does it bead up like water on a windshield? Or on the left, does it readily absorb in and darken the substrate? There is some visual indicator on how porous or how dense a concrete surface is and how much maybe surface prep you need to do. So if it's a repelling substrate, as we see on the right, depending on the manufacturer, you may have to do some mechanical prep on that surface. On the left, if you find that it readily absorbs in, you may get away with minimal prep, depending on what the manufacturer represents. But a drop of water on a concrete substrate answers a lot of questions, so some questions they may not be thinking about. But again, the simple test to evaluate porosity absorption of a concrete substrate. Now, as far as the primer application, here's some examples of non-absorbent substrates that underlayment, primer and underlayment will work over. Read the manufacturer's tech data sheet. If you're up against these type of insulations, what do they recommend? One big one, or oftentimes, is moisture mitigation membranes that are epoxy based. What does the manufacturer recommend for their product over that material? Over VCT over stone. Tile over tile is another installation that's becoming more popular or readily done. So again, read the tech data sheet. What do they recommend for these various applications, both type of product, type of primer, and type of surface prep required. If you're working with an epoxy moisture mitigation membrane, oftentimes the recommendation is to use a sand broadcast into that epoxy membrane, moisture mitigation membrane, to enhance bond, mechanical bond of whatever you're throwing on top of that. An epoxy primer is often used with underlayments or topping products that are rated for surface traffic to receive heavy traffic without a flooring material over it. Also, an epoxy primer might be useful if you're working over an elevated access floor, a metal access floor, and their epoxy works great, but a sand broadcast might be recommended to enhance bond of the products to follow. So as I've been preaching, always read the tech data sheets from your favorite manufacturer, what they recommend over non-absorbent surfaces, over metal, if that's the case. Now, once we start mixing, we talked about moisture or water is very important, but too little, too much all create their problems. And too little, too much could be just from the ambient humidity, rainstorm that day, but they affect how that product will work and perform. High humidity, high temperature, you're going to get a weakened underlayment. And other than Mother Nature and weather, you have airflow. If the windows aren't covered or doors are open or it's open air, you're going to have airflow. On a hot summer day, the wind blowing is going to change the working time, the heal rate of that product. If you have heating and air conditioning running inconsistently, that underlayment product is going to perform a little bit differently. Weather extremes or direct sunlight beating down on an underlayment surface, again, will change working time, heal rate, flow time. So you have to keep aware of all these various site conditions, weather conditions that will impact the underlayment product. Water, again, is required for the self-leveling material that activates all this various chemistry. The amount of water is very important. Too much, too little changes the chemistry that we see here. You get delamination, cracking, dusting. One area of concern, if you use too little water, that cement in the underlayment is still thirsty. So once you expose it to moisture from some other source after installation, it may swell and expand and crack. So again, too much, too little are going to be a problem. Working time is affected by how long you mix it. More is not better. If you mix an excessive amount of time, you're going to be eating into your working time with that product. If you don't mix enough, again, your flow and heal rate may be affected, as well as the chemistry on the right may be impacted. So again, the amount of water you add, how much, how long you mix it, and how well you control the environment, meaning temperature, wind, sunlight, humidity, that's very important to understand before you start your project. And here we're looking at a self-leveling product that's been overwatered. And what we see on the slide on the right or picture is that all the heavy material, the sand, has sunk to the bottom. all the lightweight material has floated to the surface, but there's no durability or strength in all that lightweight chemistry or elements or compounds or materials that have floated to the surface. So the correct amount of water is very important. Too much, too little, the death of an underlayment product. Typically, you're applying an underlayment product over concrete or wood, but there's a variety of other substrates that this product can be applied over. As I've been preaching, read your manufacturer's tech data sheet. What do they recommend for surface prep? Do they recommend their product be used over gyp or epoxy? Again, what primer? So all these things need to be answered for all substrates, but particularly some of these that are shown here with the bullet points. Now, as far as installation, you can mechanically mix the product as we see on the left, or barrel mix it. Both methods are acceptable. We've got contractors that love either system and work very well with it. The mechanical application might be beneficial where you have a large open floor area. There's no walls or other transitions. It's you could mix and go and get it all done in a hurry, so to speak. Barrel mixing might be more appropriate where maybe, let's say you're in a multi-family building, apartments or condos, for example, where you're doing underlayment a little bit in each of the units there. So barrel mixing might be more conducive to that type of environment. But whether you barrel or machine, mechanical mix, both methods are generally approved by self-leveling manufacturers. As far as the production rate, again, these are just ballpark numbers. A guy or a contractor that loves to do barrel mixing, if he has a very large project, he'll gear up. He'll have enough personnel, enough barrels to mix effectively without jeopardizing the installation. So both methods are fine for working with self-leveling products. It's important when the self-leveling material is poured from one batch to another that you maintain a wet edge. You don't want a cold joint to form between adjacent pores. That cold joint could potentially reflect through and be evident on a on a LVT or vinyl type installation. So you always want to have enough personnel to mix and maintain and apply batch to batch with a wet edge. Or for example, if it's a hot, windy day, make sure you've got the equipment and manpower to maintain that wet edge. Another concern with maintaining a wet edge, if some of the underlayment starts to cure and harden and you pour a new batch up against it, that new material may flow up and over that already cured material and create a hump. That might be a problem if you're installing vinyl or sheet type flooring. So wet edge is very important, and that wet edge requirement is impacted by type of mixing equipment, the personnel on the job site, and weather and environmental conditions. So that all has to be kept track of to get this installed correctly. Once the material is poured or placed, you use a gauge rake to move that, to distribute the product in generally a uniform thickness. Once the gauge raking is done, the contractor will typically run over the surface with a paddle. With the paddle helps distribute product, but it also opens up the material. So if there's any air that's been trapped in the underlayment during the mixing process, it allows that air to escape, smooths the surface, gives you a nice mirror finish that's very important or expected for that installation. And once you have that material placed, and depending on the product, you've got maybe about 20 minutes after mixing to get that product placed, gauge raked, paddled. And once you hit that 20-minute mark or whatever the manufacturer tells you in the tech data sheet, you don't touch it again. Look in the background of this picture. The surface is dull, flat looking. It's lost its sheen. That product can't be touched again. You may be able to push your thumb into it, but you cannot manipulate it or work it with any type of tool, because that tooling will remain as a defect, a low point or potentially high point. The product that's closer to the foreground maybe that's still workable, but understand your working time. Don't eat up your working time by excessive mixing. If it's a hot, windy day, low humidity, whatever, your working time is going to be affected. So understand what it is, so you don't get cut short. But after the working time, all you're doing is looking at the great job you did. If you have to correct the surface, it's done after this product hardens and that you can get on it. Trying to correct the defect in the installation after the working time creates more problems. Moisture. Moisture in a concrete slab comes from different sources. Obviously, there's water mixed into the ready mix for workability, placement, and cement chemistry or hydration. But water might be inadvertently added during installation, where here we see the contractor is spraying down the substrate there, trying to, let's say, lubricate that surface so all that ready-mix concrete can flow under, over, and around that steel or rebar there. So the contractor is incorrectly adding more moisture to that slab that eventually is going to have to leave, which can impact your flooring installation. And we'll talk about that. Once a concrete slab is placed, if you've got concerns with excess moisture either being added by Mother Nature here with a rainstorm, or if there's no moisture vapor barrier plastic underneath the slab, you may have a continuous source of moisture coming up, which we know is going to screw up your floor at some point. The unwritten rule that it takes 30 days for every inch of concrete to dry. So if you have excess moisture because the contractor was adding it during installation, your dry time is going to extend probably. If you have a rainstorm soon after the concrete is placed, you're going to extend the dry time. So you as a contractor have no idea how dry that slab is. Is it dry enough for underlayment? Is it dry enough for any of the tile setting products? Read the tech data sheet from the manufacturer. What do they require for minimum or maximum moisture in that slab? And if there's a concern about moisture from any source, the soil, contractor error, or Mother Nature, you can determine too much, too little moisture by moisture testing the surface. And there are two tests: the calcium chloride test on the left, RH meter on the right. They measure different things in different ways, but you can find out, do you have excessive moisture? Can you allow that slab to dry out? If you can't, you may want to be using a moisture mitigation membrane over the concrete. Digressing maybe a little bit, there's two tests. The biggest difference between these two tests is the depth of measurement. Calcium chloride gives you a moisture reading from the moisture that exists in the top half inch. RH testing goes much deeper. And why is that important? The minute you put right now, both slabs, left side, right side, they are in equilibrium with the air. Nothing is pulling or pushing or causing all that moisture in the bottom, all those blue dots, if you will, to rise to the surface, because the slab is in balance with the air on both sides. Now, on the left and right, if we put a flooring product down, now the slab is going to try to equilibrate between the bottom and the top of the slab. So all that moisture that's sitting in the bottom will suddenly want to move to the surface. With the calcium chloride test on the left, you have no idea how big that reservoir is. And if you do a calcium chloride test and it tells you, wow, I'm fine with moisture, and you put the flooring down, you're going to have problems. Whereas the RH test, which goes deeper into the concrete, you get a good indication of how much moisture is sitting at the bottom that's potentially going to move to the surface once you put your flooring product down. So if you do moisture testing, RH testing gives you a more meaningful result because it's telling you how much moisture is in that slab sitting there in a reservoir, so to speak, that's going to possibly migrate to the surface. Calcium chloride on the left gives you no indication of how much moisture is there. Bottom line, for any tile setting product you use, read the manufacturer's recommendation. They may recommend calcium chloride test. They may recommend RH testing or both, but make sure you understand how that manufacturer wants that substrate tested for moisture before you proceed. You don't want to void a warranty because you got the wrong test results. And typically for the calcium chloride, most products that we're talking about today, generally you're at no greater than 5 pounds of moisture. In the case of RH testing, somewhere between 75 and 85% is the maximum. So if you exceed those values, you're going to have to use a moisture mitigation membrane as part of your surface prep. And the moisture mitigation membranes are 100% solid epoxies. They're good up to 100% moisture, 100% RH, or typically around 25 pounds of moisture based on the calcium chloride test. So we've talked extensively about surface prep, primarily flattening the surface, but moisture mitigation may also be a requirement, because today you don't have the luxury of time to wait. If there's excess moisture, you can't wait weeks or months for it to dry out. No project will allow you to do that. So moisture mitigation may become a very important part of surface prep. I'm done. Some people may be saying thank you for that. Appreciate your time. If there's any questions, I could field those now. And I just like to restate, you see my email address there. If you need a certificate of completion for continuing education, email me. If you'd like a TCNA handbook or an ANSI standard book or both, email me. Or if you got questions that arise after this presentation, do chase me down. But bottom line, thanks for your time. And Jim, any questions? And
So
Jim,
Howard,
only give me questions that I know the answer to, please.
well, let me throw a few comments out first real quickly for everyone. So great job, a lot of information there. One of the things is Howard kept referring to SLU, so self-leveling underlayment. That is
Yeah,
no longer we use. We use FHU or FHCU, which is flowable hydraulic cement underlayment. So
yeah,
that's the correct name.
yeah,
You're going to
thank
see
you.
it as SLU out there all the time, but I just want everyone to know that the correct name is FHCU or FHU, or
All right.
flowable hydraulic cement underlayment.
Yeah, I
Howard
thank
also
you for
mentioned
keeping
a
me
couple
honest on
times
that one.
Howard also mentioned a couple times during his presentation that refer to manufacturer's recommendations. So for all these products, look at their recommendations because they supersede anything in the methods and standards of our industry. You always follow the manufacturer's recommendations. They're the ones backing the product and will be there for you. Very, very important. In the beginning, he mentioned large format tile going from 15 inches on one side to over 23 inches. And I just want to make a comment that a lot of you may still have an older ANSI A108 book, and that has been fully reformatted and rewritten. NTCA Becky Serban, who is our education and curriculum director, worked with manufacturers and tile contractors, installers in our industry. And over a year of rewriting it, it was reprinted and published in January. So it's just out there now, and it will have all these new standards in it. So it's A108T. T stands for terms. And in there it says large format tile is defined as a tile complying with ANSI A137. And in there it says greater than 23 inches.
Yep.
Other than that, I just wanted to correct those before we get to questions. Okay. All right,
Yeah.
Howard?
Yeah, as far as the ANSI book, again, it was printed January 2024. If you ask for a copy, that's what you're going to receive, the most current edition with the changes or updates that were mentioned in your comments. So
Yeah, correct.
again, thank you for filling in the blanks on some of my misstatements, I guess.
You didn't miss statements. It's just I thought I'd give a little bit more information. All right, here's a
All right.
question for you, Howard. If a slab is curled due to the edges or the bottom drying, curing before the center or top, and then he flattens the slab with FHCU.
Yep.
Once that cement slab cures, will that FHCU make a hump in the floor?
So you have a curled slab and depressed in the center, going from one construction joint, and you fill that with a leveling material. Will that form a hump at some future date? Is that what I'm understanding?
Once it completely cures, yes.
Well, the problem you may have, and I'm not sure if it would create a lump, is that if you have a curled slab, because it dried out on the surface quicker than it did the bottom, it may relax again once that environment or room is acclimated, or bottom line, it has dried uniformly. Whether or not it forms a lump, I can't say that that's the case. I'm drawing a blank on a good answer for that. Uh, Slab relaxation is a potential, but how that would impact the flattening or leveling material, I can't really say. I'll have to do some nosing around with my technical side of it and get an answer back to that comment. Whoever made that comment by
Great.
email.
And if you just relay that to me, Howard, I'll make sure they get that answer. That's great.
Okay. Okay.
All right, the
All right.
next one. If you have puddling with the primer and it dries, how does that affect the consistency of the the thickness of that product, and how would you deal with that?
Well, really, you don't want you want that spread a puddle, and I guess I couldn't define what is a puddle. Is it a 32nd to a 16th of an inch? But you want to spread that out as thin as possible. And again, the idea is to where it, if you have any low spots or where it's absorbed in, that's what needs to be corrected. If you have it too thick, it may not dry uniformly. It may be still, I'll use the word tacky, or not completely cured, impacting its strength or function at that point. But you want that primer dried prior to the underlayment being applied. Uh, uh, does that answer the question?
Well, I think so, and if not, I'm sure they'll reach back out, Howard. So yeah, great. All
All
right,
right.
next
Oh,
question.
another question. All right, go ahead. Go ahead. I'm sorry.
No, it's okay if you wanted to answer more.
Yeah. Another thing too with the primer product, I've just got a text message about that. Is that potentially, if it's applied too thick, and it may peel off and debond like a sheet of plastic. So again, more is not better with many of these materials that we're talking about, as far as applied thickness or mill thickness, etc.
Well, if we have more questions on that, an email will be coming to you tomorrow, and you guys can reach out to us and ask us, and we'll try to clarify that. Thank you. When self-leveling or self-flattening, is it wise to cover windows that get a lot of direct sunlight on that area?
Well, I would say so. Again, sunlight on the surface of the underlayment will, cause it to dry quicker. You're going to lose working time. You're going to lose shorten the healing time on that surface. So again, if you've got sunlight coming in, as much as you could cover or covered, that would be wonderful, or a good idea. If it's an area that's largely open air, maybe trying to install on the side of the building that's in the shade versus trying to do that on the sunny time of the day. But yeah, sunlight or any sort of heat source on that surface, you lose working time, heal time, flow rate, all negatively impacted.
Great. All right. So if an architect uses ACI 117 to address the slab and how it should be poured when receiving I'm trying to just see if I understand this. So they're going to use a 24 by 48 tile. Does ACI 117 address how to pour that slab?
I'm not intimately, I apologize, I'm not intimately familiar with that ASTM to answer a yes or no to that question. If it addresses all the needs relative to a tile, a subsequent tile installation, I can't answer that question.
Okay, Mickey, I'm sorry that we don't have a good answer for that, but I'll try to look into it and get back to you for that answer. Other than that, Mickey, she said, or he said, Mickey said, he or she, I don't really know, I'm sorry, that the answer you gave was great, so we're fine. So,
All right.
Howard, do you have any last minute information or any
No,
notes?
again,
Or anything you want to say?
thanking everyone for their time today. I hopefully, again, it was an hour's worth of presentation, but there's a lot more information if you need it. We or Custom or any of the manufacturers are a good resource to talk about their products and the issues that we touched on today on floor prep. And again, today's presentation give you a good inkling on what to do right. If you need more help, you know my email address. I can answer that, or people smarter than I in our organization can also do that. So again, thank you very
Notice
much
on
for
the
your
bottom
time.
of it, on the bottom of this slide is Howard's email address for the one more time, hjancy@cbpmail.net. Again, you'll get an email from me thanking you, and you can reply to that tomorrow too if you have any other questions. So that's great. I want to thank you all and really appreciate everyone spending an hour with us, a little over an hour. We will have another webinar this month, actually April 18th, right before coverings. And I hope to see all of you at coverings, but please get ready for an invite coming to you soon for the April 18th webinar. Howard, thank you. Everybody, thank you. Have a great day and weekend.
All right, thank you.